Whew! There she is, Miss McAdams. And hey, guess what? We're going to be looking at Dilations today. If you remember, I used her as my example for Dilations, my celeb crush. Don't hold it against me. She does a great job in the notebook if you haven't seen it. So let's look at 8.5, Dilations. You're almost home. And dilations are super simple. I think you're going to do a great job with these. So let's look at dilations. It says a dilation is something that makes an object bigger or smaller. And so as we saw in the very beginning, 8.1, saw the images getting smaller here and bigger here. But let's talk about those important facts. And dilations are actually very interesting because, for starters, dilations are not isometries. Alright, because you remember an isometry is something that preserves distance, right? Well, with this getting bigger and smaller, that's not going to work out the way that we wanted it to. A dilation does, however, preserve orientation. Alright, because remember, even if it's getting bigger or smaller, the points are staying in the same spots. Nothing is changing about that. Because dilations don't preserve distance, they are similar. Image and pre-image. Alright, this is different because remember with the other ones we've been saying a congruent image and pre-image. Dilations are similar because of the same size, or excuse me, because of the same shape, but they are not the same size, so you can't call them congruent. Instead, they're similar. And finally, with dilations, there are no invariant points. Every point is going to move. Nothing stays the same. Everything is affected. All right, so dilations are actually pretty interesting when we look at our 4 facts as compared to some of the other transformations that we've done. Now, there's a key term when you see the word dilation you have to think of, and it's called a scale factor. All right, now the scale factor is simply the number you multiply by. And that number just tells you how much bigger or smaller it's going to get. So let's look at this first example. It's a scale factor of 2. So that means we're going to be multiplying these coordinates here by 2 to get our bigger triangle. So the notation that you're going to see, or how it will appear like on a problem, it'll be a big D like that, and then a 2, right? Because the scale factor is 2. And an uppercase D for dilation. Alright. And now for this one, we can have fractions, but don't freak out, because remember, it's just multiplication. That's all that scale factor means. It means that you take each one of these coordinates of your triangle and you multiply them by a half to get your new image, right? And how is this going to be notated? Well, you'll still have the uppercase D and then the fraction 1 over 2. So the notation's pretty easy. And the other thing I wanted you to recognize is that scale factors can also be negative. But that doesn't necessarily mean the object's getting smaller. It just means that it's moving or changing in some way. So don't necessarily just assume if you see a negative it has to get smaller. It might just be moving, okay? So now let's look at some example problems. So you've seen the notation, you know scale factor, dilations you'll move through pretty quick. Let's look at this first one. What are the coordinates of the point 3, 4 under these dilations? So all I do is I take my x and my y, which are 3, 4, and I multiply each of them by 3. Right? So after a dilation of 3, 3 times 3 is 9, 4 times 3 is 12. And I'm done. Now let's look at a dilation of negative 3. Well, same thing. I'm going to take my points 3, I'm going to take my point 3, 4, and this time I'll dilate it by a negative 3. And so 3 times negative 3 is negative 9. 4 times negative 3 is negative 12. So if you were to graph those points, like that point necessarily didn't get any smaller, it just moved to a different coordinate. That's what I was talking about with assuming that the scale factor being negative also means that it's going to get smaller. So now example 2 is we're dealing with a fraction, but it works the exact same way. So I have negative 6 comma negative 3, and I am going to do a dilation of 1/2. So what is negative 6 times a half? Well, you can put in your calculator. It's -3. What's -3 times a half? That's -3 over 2. Yes, it's okay to have fractions. We're okay. Don't freak out. You can just write it like that. We'll take the decimal as well. Just understand that a dilation, all you do is multiply. All right? Now let's try to make it a little more difficult. Third problem says the point A, -2, -4, moves to 6, 12 after some kind of dilation. We want to find the scale factor. Now, if you remember, the scale factor is just what you're multiplying by. So we have to figure out what we're going to multiply by to get from -2 to 6 and -4 to 12. It is the same number. For a dilation, we use the same number for x's and y's. So it's only one number. So it's -2 times some number is going to give us 6. And it's -4 times some number, which will give us 12. Well, I'm sure you already know this, but it's -3, right? And it should be the same number for both. So what is the scale factor? The scale factor equals -3. And you're done. Simple, right? The fourth problem. This is as hard as I can make it for you, and you'll see how easy it is. It says the image of V after a dilation of 4 is this new point 16, -32. And they want you to find the original coordinates. So we have some coordinates that we don't know. We had a dilation of 4. I'm writing the capital D because dilation. 4 because we multiplied by. And they gave us 16, -32. So if I multiplied by 4 to get from this to here, to go backwards, I do the other operation. So I just do 16 divided by 4. And that'll give me 4, right? And -32 divided by 4 will give me -8. So all I did was the reverse operation. I just did 16 divided by 4, and I did -32 divided by 4. What if it was a fraction? Well, it's still multiplication, so then you just divide by the fraction. The point is, if you're going this way, it's multiplying, and if you're going back this way, from right to left, it's going to be division. That's all I have for you. The rest of the problems, I think you'll fly right through. There'll be a little bit of graphing on there, but I believe in your abilities to do a great job. You've mastered dilations. Go watch The Notebook if you've never seen it. Richard McAdams is amazing. All right, we'll see you next time.